Session hijacking takes place after a client has established a session with a server. Client says hello, this could be TCP, SYN, SYNAC, ACK. We have a relationship established. A session is really just a relationship between a client and a server that is existing. So the client is able to communicate with the server, and the server knows who they are. So the client establishes a session, they have a great time, this session isn't terminated, and now we have a malicious actor or system that's going to impersonate the client to the server. So the server sees these requests as being part of the same session and answers the request as if it's the original client. So we've taken advantage of an existing session or hijacked this existing session. So our examples are TCP or HTTP as common examples. In TCP, we have our sequence and acknowledgement numbers that take place after we've established our session with SYN, SYNAC, ACK. And if a malicious actor is able to guess the next sequence and acknowledgement number and spoof an IP, they could hijack a TCP session. More common is hijacking of an HTTP session. So HTTP takes place over port 80 using TCP. HTTP itself is stateless. You're requesting a resource. That resource is provided to you. That page is provided to you. Websites, to make the experience seamless for the users, added states on top of HTTP by using cookies. So session hijacking over HTTP typically is cookie hijacking. You establish a session with a website, maybe you log in, provide your password over HTTPS, that website provides you a cookie. You now use that cookie or session ID when you're communicating with the website to say, hey, we already talked about this, I am who I say I am, please provide me my data. And if you use unencrypted Wi-Fi, public Wi-Fi, and use websites that only do the initial negotiation in HTTPS, but all your subsequent requests have your cookies sent in clear text using HTTP, it is very easy for a malicious actor at Starbucks to hijack that HTTP session.